Okay, so in the previous video, we found that the PLC SIM was awesome, but it doesn't allow us to modify physical input bits, right? Things that exist in the real world. So what we're going to do is I'm going to introduce a new topic, memory bits. In this case, we're going to change our inputs to %m0.0 and %m0.1. So instead of looking at physical inputs that exist in the real world, we're just going to look at memory bits that are within, like little bits of information that are within the memory of the PLC. Okay, so you can see here that I'm going to change my % input 0.0 to %m0.0. And these numbers right here, again, they correspond to, like the 0 right here corresponds to the first word of information. So 16 bits of information there. The second number here corresponds to the physical bit of information within that word there. So this is the first bit of information, so that's our 0. So remember, everything starts at 0. Okay, the second bit of information is going to be %m0.1. Okay, so that is the first and second bit of information within a 16-bit word. And as we go forwards, we'll look at like bits and words and double words, and they'll start to make a lot more sense as we start to build up our knowledge of the PLC environment. Okay, we're still making use of the normally open and normally closed instructions. Normally open still looks for the presence of a 1, and a normally closed is still looking for the presence of a 0 in the memory. But we're just changing from physical bits to memory bits. The beauty of this is that we don't have to actually look out in the real world for something, right? Or we don't have to take up an input terminal if we can look within the actual PLC program. So we'll see that by doing this, we can control other rungs, or we can store information either as a bit or as a word or as a double word. So the memory bits are awesome. They're going to open up a huge amount of space where we can allocate different memory different information to the PLC as we go forwards. Okay, so what we're going to do now is we're going to go back to our TA portal, and we're just going to change the stop and the start to those memory bits. So let's do that now. Excellent. Okay, so we're going to click on the stop push button, actually double click there, and then we'll just highlight this guy and we'll hit delete, and we're going to change that to %m0.0. Okay, and then for this guy right here, we're going to change this to the second memory bit, right? So this was m0.0, this is going to be %m0.1. So we'll double click on this, we'll hit delete, and then we'll put in %m0.1. Excellent. Once we've done that, then you can see that within our PLC tags, if I open up all my tags now, then we'll have the physical input bits that we had before, our physical output that's still there within our program, but now we have these two new memory bits here. I'm not going to name these guys stop and start push button because we already have those names here, and that'll cause a conflict. I just want to show you that I can actually modify those bits with the PLC SIM. So we're going to go back to our main OB here. Okay, and then we're just going to go and simulate the program. If you forget how to do this, then go back a few pages and it'll show you exactly how to go through the PLC SIM. But again, I'm going to show you those steps right now. So we're clicking on the image of the OB1. We're coming up here, compile, download, yes, start simulation. So we'll click this. We'll hit OK. Okay, if this isn't selected, then you're going to hit Profinet. We're going to do a search. And as it did that search, the PLC SIM icon just came up, so I'll move it back over here so you can see it. It has found my virtual PLC, so I'm going to click on that guy and load it. I'm going to hit load again. And then remember that over here, if I forget this step, I can always turn the PLC on over here, but I'm going to turn the PLC on once it's finished. So hit start module and then hit finish. Excellent. Let's collapse this down, and then let's hit the monitoring, and I'll show you how we can monitor the program and modify each of the bits here. So within the textbook here, I'm just showing you modifying each of the bits as we go through in the logic. So let's set up the stop push button. The stop push button is a physically normally closed push button. So that would mean that we would modify this one to a 1 because it's looking for the presence of 1. Oh, nice. Excellent. So now this guy is actually true. So if you missed that step, I right clicked on the stop push button. I went over to modify. I modified it to a 1. And as soon as I did that, this instruction is true. And the logic continuity came over here to my start push button. Nice. Okay, so PLC SIM in this instance is awesome because I can physically toggle the bits and modify them from a 0 to a 1 and see how my PLC program is going to react to it. So that means that my stop push button is fine. Nobody's pressed that, right? So there's voltage going in to the stop push button. That means that this is true. Now I need somebody to physically press the start push button. So that's a physical normally open contact, which when we press would put voltage into that input terminal, and that would modify this from a 0 to a 1. So let's modify this to a 1, and we'll see that the output turns on instantly. Ah, yes. Excellent. So now our output is on. That means that we are still pressing the start push button because this guy is still true. So let's modify this to a 0, and we'll see that the logic continuity is maintained to the output there. So let's right click on here again. Let's modify this to a 0, meaning we would let go of the start push button. The voltage would not be going into the input terminal. Excellent. Now we see the dashed lines there. So this is no longer true, but we have a path of logic that is still maintaining this on. This is looking at this output, and the output is on. So this is a 1 in the memory. So this is true. So this and this are true, allowing this to be true. Excellent. Okay, at this point, we would want to stop the 3-wire from working. So we would come over here and we'd actually physically press the stop push button. And in doing so, we would be modifying that in the memory from a 1 back to a 0. So once we modify it to a 0, you'll see that the output turns off instantly. Sweet. Excellent. So PLC SIM is awesome in that you don't actually physically need a PLC to make this work. In this instance, when we're using this portion of PLC, there's another cool portion of PLC SIM that we're going to make use of right here in the project view. But at this point, we're not able to change physical inputs, but we are able to change memory bits. So that's awesome because this way we can actually simulate our program, and we don't have to actually buy a $1,000 PLC to actually go through the rest of the course here. All right, hopefully everything worked out for you. The next topic that I'm going to show you is we're going to replace these guys back with the physical inputs, and then I'm going to show you how a memory bit can be made use of to turn on different portions of our program. So right now I have a physical output that's turning on, but we're going to change this to %M0.0 for an output, and then have that turn on different portions of our program. All right, guys, we'll see you on the next video.